So good afternoon, everybody. Today we are going to start the next bit from the subject plastic engineering, that is design of plastic parts. Up to previous class, we have completed 3 units, namely plastic type means introduction to plastic, then processes of plastic, and design welding of plastic. Fourth unit is dealing with design of plastic parts. So in day-to-day life, you have seen number of plastic components. So how these parts are designed? So there is a certain procedure, and how that procedure is to be followed, that will be covered in this chapter. Now, as far as this design of plastic parts is concerned, before we start the actual part design, there are certain initial some of the concepts that we are going to cover. Let me tell you the contents of this chapter. What are the contents of this chapter? It consists of types of design. Means there are different types of design whenever you take any part. So there are different types of design. Then tolerances, then allowances, then design of undercut, design of wall or minimum wall thickness, design of rib, design of holes, inserts, etc., etc. These are the contents, and at end, once we clear all these concepts, we will take one illustration. So some component drawing will be given to you, and with the help of that drawing, how can you modify or how can you write the design procedure to reach up to the end? Okay, so accordingly, so the aim of, or I'll tell, instead of aim, I will use the word outcome. So as per the procedure, we can say that outcome of this topic is, at the end of unit number 4, students will be able to design the different plastic component as per the requirement. I repeat, at the end of chapter, students will be able to design a particular plastic component. So here we will take some simple plastic part arrangement. Maybe, for example, bush required for maybe tables, chairs, etc. That will be taken, and I will tell the process which you can follow for any types of problems. So this is all about the contents of this unit number 4. Now let us start with the first content, that is types of part design. You can write part design process. If we classify this, there are 4 types of part design. First one is general. Second is structural. Third one is design of assembly. And fourth one is mold design. General design, structural design, design of assembly, and mold design. These are the 4 important parts of the part design. Now, let us see. I hope you have noted it down. So, short note may be asked, what are the different aspects of part design process? What are different types of this part design process? So it includes, I repeat, general design, structural design, design of assembly, and mold design. So in today's class, we will see this one by one. What is meaning of general design? What is meaning of structural design? What is meaning of design of assembly? And what is meaning and importance of mold design? So next line, right? General design. Now, friends, if you consider any of the plastic component, what are the general aspects? So there are different requirements. there are different requirements. First requirement in general design, this is complete theoretical part. You please understand the concept. Understanding the concept is important so that you can write the notes, short note in your own language. So what are the main requirements of the general design? What are the main contents of the general design? So it includes functional requirements. Functional requirement means how that part is going to perform, where it is used. What are the functions? I have designed this cap. What is the function of this cap? To remain in the tight position on the tip of pen. How you are going to handle it? Okay, so which function it is going to perform? Function requirements includes this mechanical loading, unloading, tightening, loosing. So what is the function of component which you are going to manufacture? This is one of the first important concept in the general design. So you can write this functional requirement. Means how it is going to perform. Okay. Then second important thing as we are considering in any of the design part is aesthetic. Aesthetic need means what? This is nowadays becomes first priority. So see how aesthetically this pen is designed. Even this cap, how beautiful shape is holding. Some of the grooves are made on it. So these grooves are provided just for proper holding. So it is not slipping from my fingers. It is in tight in the position. Then to give different look. So here some different assembly is made. So upper cap is different and which can be fitted here. So it indicates that it is used for proper holding in the pocket, etc., etc. So all these are the aesthetic concepts, aesthetic lookout. It also includes color and then level of transparency and other responses. So first requirement was functional requirement. Second requirement is aesthetic requirement. First requirement tells how it will perform or how you have planned it to perform, because you are going to design it. How you have planned it to perform and in actual how it will perform. Then what are the requirements of aesthetic lookout? So aesthetically, when even some of the things are performing well, people have little percentage of aesthetic. Okay, even if you go to purchase the bat, everybody is playing cricket. If you go in market and if you purchase the bat, so you are going to see it, its robustness, how lightweight it is, how the handle you can hold it. Apart from it, some percentage you always have, yes, how beautiful this bat is looking. So looking is very important thing. That's why aesthetic requirement, even if it performs well, it will be very good asset for the batsman by taking that bat. But if it will not be finished well, and if some color patch has removed, some rubber of the whatever handle is there, it is get teared, such bat you will not purchase. So apart from its functional requirement, aesthetic needs and aesthetic requirements, colors are also playing important role. Okay, so I repeat once again, this is general thing. So I am just clearing your concept. In what if it will be asked in the examination, you have to write with your own illustrations in your own words. It will be better because you will be in a position to work as a design engineer in some of the industries after a few months. Okay, that's why these requirements are to be considered. Third requirement. Who will tell? I will not write. Half of the word I have written. Who will tell the third general requirement? Let session be interactive. Now we'll ask Nishkalang Sapkar, because we are talking about cricket. I hope he is in the room without just joining the room. And Mr. Nishkalang Sapkar, roll number 51. Are you there, Mr. Nishkalank Sapkar? As usual. Who will tell what is third requirement? So I hope you will participate willingly. Which parameters will consider? Third requirement. So functional requirement, aesthetic requirement, and main is missing. Third requirement. In this way, if you will not respond, lecture should be it should be interactive session, friends. Who will tell? Akshay Laute. Akshay Laute. Roll number 75. Akshay Laute, roll number 75. Where are you? Hello. Rohit Adlinge. Rohit Adlinge. I will not continue if somebody of you will not respond me. Hello. Rohit Adlinge. So I will start taking attendance now. Roll number 1. Chandra Prabhas today.
Yes, sir. Yes,
Are you
sir.
listening me?
Yes, sir.
Can you tell me what is the third requirement of the general design? First requirement is that your part which you are going to make should perform well in all respects. So functional requirement. Second thing, it should look beautiful, aesthetic look. What is third requirement?
No idea about that, sir.
It is general question. Then Pratik Ingre, roll number 22. Pratik Ingre. So Pranay Surve, you can talk. You can unmute yourself and talk. Mr. Pranay.
Material requirement, sir.
Material, but this is indirect answer. You can continue your answer once. You can modify your answer. Third aspect of general design is economic concern. And now economy in the terms of what? Man, material. Man and material, man means labor. Man means labor. Labor and material cost. So, all these are the important general design aspects for part design. And friends, you are going to face interviews. Such questions may be asked in the interview. This is very general and basic topic. There is no any design part in this. This is as the 8th semester of final year, mechanical engineering. So second semester means total 8th semester. Your education will be over after this semester, and you should be in a position to explain all these things. So that's why lateral study is also important along with longitudinal study, and it is part of syllabus. I'm not telling about. So you should have this general idea about any of the things which you are going to prepare, which you are going to design, which you are going to sell in the market, etc., etc. So these are the aspects of general design. Second, structural design. structural design. Now who will tell? Pratik Ingre is there? Pratik Ingre. So I'm noting down all these roll numbers. Roll number 22. Prashant Tange is there? Prashant Tange. Roll number 67.
Yes, sir.
So, what is your idea about structural design? What is your idea about structural design? What aspects you are going to consider when you are going to design the part? So, you are the design engineer and you are going to design one plastic component. So, what kind of requirements you will think while designing? You are the design engineer. Roll number 67. Prashant.
Yes, sir.
You are design engineer and I have asked you to design one plastic component. So what is your idea about this structural design? Tell.
Strength and rigidity of structures.
Correct. No problem. So you go on telling, answers will be correct. So your primary design will come first in brain, then it will come on paper, and then it will be executed. So you always think it will perform, it should perform well with its strength, its rigidity, how functionally, see in general design functional requirement we have seen that. So here also, what are the different stresses produced, or probably maybe this part will come across so and so stresses, and accordingly you are going to design this part by considering its structural aspects. So you have to meet the structural requirements. You have to meet the structural requirements. Accordingly, after first priority of general design, second priority structural design includes the functioning of the actual part at some particular assembly. Your part which you are going to design, it may be one of the part of assembly. I repeat once again, your part which you are going to design may be one of the part of assembly. So how it will perform there and how it will meet the structural requirements. If you are going to manufacture any nut, just simple example I am giving. If you are going to manufacture any plastic nut, okay, so nut may have some inner threads. You are going to tight something with the help of nut, and with the help of vibrations, it may become loose or it may get cracked. It will of no use. So, what strength is required? What kind of torsional stresses it can sustain? All these requirements are considered in this structural method. That's why whatever design you make, it should meet the structural requirement. It should meet the structural requirements. Third is design of assembly. So now let us see who are awake. I will take the names. Akshay Laute. So I am writing roll numbers here, those who are not responding. Akshay Laute. Shweta Nistan is there. Roll number 6. Miss Shweta.
Yes, sir.
Now I am asking you, what is your idea or what is your opinion or what is your thought process, or what you think about this third aspect of part design, design of assembly? So some of the part I have covered in previous second point. Design of assembly, what is your opinion? How you think? How can you write 4-5 lines about it? Tell.
सर मी गेले लेक्चर अटेंड केलं नव्हतं.
There is no relation of previous lecture with this lecture. Previous lecture was building. This chapter is new chapter.
नो आयडिया सर.
You should think. You give stress to your brain. Try to answer something. Huh? Now assembly. How to make assembly? Think over it. How you are going to make assembly? Tell. Ajinkya Jadhav, roll number 23. Roll number 23, Ajinkya Jadhav. Roll number 23, Ajinkya Jadhav. Roll number 30.
Yes, sir.
So Abhishek, please tell me, so design of assembly, what is your thought about the word assembly, assembly of plastic, and how can you do it?
Sir, first of all, we should require the part list which are required for the assembly.
Okay.
Then material.
No, don't go to material now. How can you make assembly? Tell me in 2-3 words. What are the different methods of assembling the parts? One word you can tell, joining.
Joining.
Process. How can you join the part? You can join the part by mechanical fasteners, maybe nut, bolts, rivets.
Or welding.
Correct. Welding process already we have studied in chapter number 3. Then bonding. So there are different bondings are there. Okay, adhesives are there. So mechanical fasteners, welding, other joining techniques, adhesive bonding, and other techniques. So this design of assembly, what it covers, the above methods and their design implications are focused. And so above methods and their design implications are focused. Means if you are going to use welding process, so in case of welding, see friends, we have studied welding chapter, welding of plastic. So there we have studied. Now your part is suppose complicated part. I'm going to explain what is meaning of design of assembly. So design of joint we have studied in high frequency induction welding. You know that you are going to design this part. So in this design, in this part design, see this is plastic cap and this is assembly of two. This white part is different and black part is different. Your total product is this and it is made up of two components. And you are going to, it may be just tight interference fit here. Consider that this is joined here. So if you want to fix this black part with white part, what kind of design of joining you have to make? Which type of welding you will select? How you design this joint? Whether it will fulfill its requirement? Are you getting my point? So these all concepts are design of assembly. So everywhere part design, topic name is part design. So topic name is part design, and in this part design, So there are different aspects. So when you are going to design the part, what are general aspects you should think? When you are going to design the part, what are the structural aspects you will think? When you are going to design the part, what are assembly aspects you will think? So this is assembly aspect. What I am telling, this component I am showing, this is best example and illustration for you. This is made up of two components. This black part is different and white part is different. Now currently it is just interference fit, but assume that it is welded here or joined. So it is not a simple thing. Yeah, yes, I will design this, I will make and I will join. You should give thought process on it. How come I join this black part with white part? Then what kind of, if I am using high frequency induction welding, what kind of coil is required for it? What kind of how much quantity of current I require to transfer so that it will produce the good joint? Whether I am going to use hot tool process for it, whether I am going to use nuclear welding for it, or just simple fasteners I am going to use. So that designing you have to make. And that is covered under design of assembly. And last is very important in part design. You can say heart of this design. Last is, fourth aspect is heart of design. Your heart of design process. And that is mold design. Very important thing, friends. I will give an example. You want some end user application. Okay. So I start with first. Our first was general design. Yeah, functional requirements. Economically, it should fulfill economical requirements. It should work like this. So that's why I was giving an example of bat. Now forget about bat is made up of wood. Here wood is not going to melt and pour. So wood is different thing naturally available. So some part you are going to make by plastic. Now, so let me talk in Marathi. एखादा कंपोनंट असा आहे की हे असं एवढ्या किमतीलाच यायला पाहिजे, असंच वर्क व्हायला पाहिजे. त्यानंतर दुसरा आस्पेक्ट हा असा दिसायला पाहिजे. नंतर हे जॉईनिंगच्या वेळेस I will convert all this translation in English. Those who didn't understand. Should fulfill that requirement. Then second thought you are putting, it should look like this. And then third requirement, you can join these two components like this. But main question is that how to make this and where to make this. So where to make this? You are going to make it in the mold. So are you getting my point? You are going to make it in the mold. So that mold is not ready-made available in the market. In subject manufacturing process. So casting. So you are going to design anything. So that mold you have to prepare. Suppose sand casting you are using. So you have to make that mold. How? By making the pattern. And then that pattern is making impression. And then that impression cavity you are using it as a mold. If it is metallic mold, you are going to manufacture it by machining on CNCs and machining centers. So this, no doubt, plastic molds, molds used for making the plastics are metallic molds. And they are machined, maybe initially casted, and then later on further machining is required to make them smooth. Because plastic component which you are taking out from the mold, it is a unique component with good surface finish. Quality of surface finish of, or in just I use simple word quality. Quality and other aspects of your component depends upon quality of mold. In one stroke, you have seen your plastic chair, how smooth it is. In one stroke, it is showing such good surface finish and unique component. So how good quality mold would have been used there. So mold design plays very, very important role in part design. I repeat, Mold design plays very important role in part design. This may be on MCQ or it may be asked in the interviews. So if any plastic component you have to design, what is the most important aspect? So most important aspect, I repeat, is mold design. Mold is what? Mold means some metallic part made in two house, two plates or three plates. Now this two plate mold, three plate mold, whatever you are making, it is having the shape of the part to be produced. It is machined in with the help of some machining center or CNCs or VMCs. That thickness of mold, material of mold, okay, coatings provided or required on the mold, then venting required for the mold, proper cooling arrangement required for the mold, accommodation of proper cooling arrangement in the mold, and last and important thing, accommodation of proper ejector system in the mold. See how important mold design is. Mold is the core, means you can say the important, without which if you didn't understand mold design means you didn't understand. Almost 90% weightage is given to mold design. So I want to say, when any plastic component is to be manufactured, first thought process should be given on the mold. Because you are going to manufacture 1,000, 10,000 pieces, 1 lakh pieces, and same mold you are going to use. Always remember, I repeat once again, if cost of your plastic is a disaster, so this maybe this part get assembled with the help of this cotton, and then with the help of stamp, it may be they may be selling this product may be 50 rupees, but actually manufacturing cost may be 5-10 rupees, less than this. So 10,000 dusters I am going to manufacture. Or you can take cap, this white cylinder only you consider, white hollow cylinder. It is having some threads inside or press fit arrangement. 1 lakh such components I want to manufacture. So for manufacturing 1 lakh such component, it is withstanding. What is withstanding? Mold is withstanding. What? Thousands and lakhs of thermal cycles. I repeat once again, whatever mold you are going to manufacture, that mold is withstanding thousands and lakhs of heating and cooling cycles. And it should sustain for a long time. That's why this mold design is very important aspect of part design. And anyhow, to ensure the quality of final product, it is necessary that correct part design. So we are talking about part design. I will come at the end of this discussion. Why part design we are focusing? You have to ensure the quality of product. You have to ensure the quality of product. So to ensure quality of product, first requirement is that you should ensure correct part design. So whatever we are talking about is all this first thing. From last 1 hour, whatever we are talking about, it is about this thing. So to ensure the good quality of product, you have to ensure correct part design. So once design is okay, no problem. So here 30% for you all. Yes, now my product, I have designed it well. It will be good. So 33% or 30% assurance you are giving. Then second aspect, to have or to ensure good quality of product. What is second aspect? If you have good part design, but your material is not good, your part will fail out, your design will not perform. So assure correct selection of material. I hope you are writing down this. So I repeat, to ensure good quality of final product, the requirements I am telling, out of that, first requirement is correct part design. So what is meaning of correct part design? That I have explained is these previous 4 parts. So correct part design means general design, structural design, design of assembly, and mold design. And how mold design is important, that I told. So third thing, after correct part design, second thing is correct selection of material. So you have ensured correct part design. I have solved case number 1. I have solved this case number 1. I have ensured that part design is correct. I have followed all these 4 methods. Second insurance is correct selection of material. Now I have selected correct material. Third thing is your processing of the plastic. I want to manufacture this cap. I have designed it well. I am pass in step number 1. Now I have selected this some material, some PVC or PET material I have selected. I have passed the second step. But if you will not process correctly, you will not get good quality part. If you will not process it, you will not get good quality part, because processing means there are 4 to 5 methods of plastic molding processes, starting from injection molding, then blow molding, extrusion molding, then rotational molding, compression molding, transfer molding. Looking at the size of component, shape of the component, how it is manufactured, this white part is manufactured by injection molding. So processing must be correct, and then only you can assure to the customer that yes, this product is of good quality. This product is of good quality. And these 3 criteria plays very important role. You can make star and write down this. To ensure good quality of product, the designer must ensure correct part design, correct selection of material, and correct or selection of processing of plastic. Proper selection of processing of plastic. So this is all about the concept, this part design and assuring the selection. In this chapter, there are a number of small bits which include tolerances, allowances, then design of rib, correct wall thickness, design of holes, etc. So remaining part you can cover in the next class. And then once all these design aspects are over, tolerances, allowances, then design of rib, design of plastic, wall thickness, then actual design procedure for part design, which is the part of question paper, means in examination on unit number 4, one numerical is asked always. So that is important. So we will stop here. Just wait 1 minute.